Hey everybody, it's Feross, and welcome to this talk on the dark side of open source. I'm really excited to share with you some of the lesser explored parts of open source. We're going to dig into some examples of malicious code and going to give you a sense for some of the threats out there in the NPM and JavaScript ecosystems. So let's get started. So first off, a little bit about me. I started out in open source. I worked on some pretty popular packages, including WebTorrent and Standard.js. And I'm also a former member of the Node.js Foundation board. And so I really got to see, a massive increase in the usage of open source within companies and in the community. Then I moved into more of a security focus. I taught the web security course at Stanford. And now I'm working on open source security at Socket. So real quick, just a couple words on Socket. So Socket's a tool that helps protect your code from everyone else's. And we help developers and security teams to ship faster and spend less time on security busy work by helping them safely find and audit and manage open source software. We have a ton of companies using us. A lot of these are actually open source projects, and we're protecting over 250,000 repositories today. So I'm really happy that we've been able to help protect the community to this degree. Okay, so let's talk a little bit about our applications. So in the last 5 years, the way that we write software has really changed. It's undergone a really massive shift. Today, it's really common to see applications where over 90% of the code comes from open source dependencies. And so that means code that your developers, you and your teammates didn't write. The average open source dependency actually has 79 transitive dependencies. So in this world where your application is built on thousands of dependencies, software security is not just about your code. It's about every piece of code that you depend on. And so in this talk, we're going to be talking about open source dependencies because we're JavaScript developers. But this is actually a broader issue. If you think about, there's this term software supply chain, and that really includes all the third-party code that you rely on, whether it's APIs, cloud services, and even dependencies like your operating system. Really, all the parts and the pieces that make up our software is what we talk about here when we talk about supply chain security. And unfortunately, the open source ecosystem is under attack. We've seen software supply chain attacks surge in the past couple of years. There's headlines pretty regularly about different breaches and attacks, and these attacks impact all types of companies. It's really just anyone who depends on open source, and I know you do depend on open source, will at some point be affected by one of these attacks just because of the scale of NPM. And so, how many of you have heard of the SolarWinds hack? This was pretty big news a few years ago. It was a sophisticated supply chain attack that compromised a supplier called SolarWinds. And the way that it worked was that an attacker added malicious code into one of SolarWinds' software products. And then they did this by basically getting into the network of SolarWinds and adding their attack code into the SolarWinds product. And then downstream of that, they were able to get into thousands of networks of SolarWinds customers, including US government agencies and large corporations. And while it's pretty hard to kind of figure out the exact monetary damages of this attack, the costs associated with the investigation, the remediation, and the increased cybersecurity measures as a result of this was probably in the billions of dollars. And so, that's SolarWinds. That's a company that has a security team and a lot of effort to defend their products. Now let's talk about like NPM packages, right? Which are often maintained by individuals or small teams of volunteers. So sometimes software supply chain security can be kind of abstract, right? It's kind of like, what are we talking about here? So I wanted to make this really concrete for everyone and just really show you what does a supply chain attack look like? So here's a real example. This is an attack that we detected a few days ago, and we're going to discuss like what's going on here. So let me help you out a bit. I'll highlight a few parts of the code here. Does that help? So now if you look at this, you can see we're a developer to install this package. This malicious code would immediately run in an install script, and it would exfiltrate or steal their environment variables, which can include obviously secrets, tokens, keys, and then it would send it to an attacker-controlled server. So you can see those three parts there. It's requiring the network package, it's accessing the environment variables, and then it has this sort of obfuscated or hidden network request down there with on that third line. And this is really how a software supply chain attack can lead to a breach at a company, right? Now, this package was targeting probably Airbnb, given the name of the package, but honestly, we don't really have all the details on what the goal of this package was. But the name is very suspicious. I'll just say that. And so fundamentally, the problem here is that, as developers, we're using so many packages, but we just don't have the time to read every line of code in our dependencies. And so we're always trusting other people fundamentally. And open source is built on trust. And for the most part, this trust is well placed. Most people are good, but there are a few bad apples. And unfortunately, it does take us as a community a little bit too long to find these types of bad packages today. Right now, we're looking at over 200 days to detect a malicious package as a community, and so this is pretty bad. This is from a research paper published in 2021. And the other big problem is when we find these malicious packages as a community, we report them and they get taken down, but they're often not cataloged and saved in any way. So they don't go into the typical vulnerability tracking systems like the National Vulnerability Database. They just get taken down, and then no one knows whether or not they may have installed that package in the past. So we're trying to change this. At Socket, we are detecting and preventing over 100 of these types of attacks every single week. And we're scanning all the most popular open source ecosystems, including NPM, obviously, but also Go, Python, and Java. And then when we find a malicious package, we report it to the NPM registry and get it taken down so that we can protect the whole community. And obviously, we're doing this to keep everyone safe, and because it's the right thing to do. But also, Socket is a commercial product as well where we sell some services. So now I wanted to just maybe spend some time going over a recent supply chain attack that I think was particularly interesting. So this one comes from December 2023. So this was only a few months ago, and you might have even heard about this or seen the headlines. Let's get into it. So this is a real world example, and in this example, so there's a company called Ledger, which makes a hardware security wallet that helps people store their cryptocurrency, and they have a JavaScript library that they published to NPM that was compromised, back in December. And the way that it worked was hackers were able to get their code into this NPM package, and then that affected all the downstream users of that package. So, the way it worked was somebody got access to a former employee's NPM account, because when they left the company, the company forgot to take away the access for that former employee. And so when that former employee's laptop got malware on it, basically hackers were able to get onto that former employee's laptop. They were able to use their NPM credentials that were just sitting there to access that employee's NPM account. And then from there, the hackers were able to get in and publish a malicious version of this library. And that malicious code ended up, it was designed, as you would expect with crypto, to just steal all the cryptocurrency of anyone who was using the library. So let's talk a little bit about how this worked. I think it has a few lessons in here for us as JavaScript developers, so that we can improve the security of our applications. So let's just go through it. So the first thing you'll notice about using this package is, if you read the README, developers who were using this library, I should probably mention really quickly what the library does, actually. So the library was used if you're building like a website and you want to talk to this hardware device, that you would install this NPM package to be able to interface with the hardware device in a more seamless way. So there are a lot of websites out there that were trying to interact with this hardware device that were using the npm package to do so. And so the way you'd use the package is the README had this line in it where it says to add this connect kit loader package as a dependency and then use it as below. So it looks pretty straightforward, right? I mean, you just import the package and then you call the loader, this load connect kit function. And then if you notice, there's another part of the README that says that this will allow your decentralized app, which is basically your website, to load the connect kit library at runtime from a CDN. So that they can improve the logic and improve the product without waiting for people to release new builds. So right away, that sets off my alarm bells, because we see here that the code that we're depending on is actually itself depending on more code, but this additional code is on a CDN. So what does that mean? That means that's code that can change. It's loading that code from a remote server. So let's look at what this actually looks like. So if you actually go into that function, you'll see that this function doesn't contain the logic of the actual functionality that I'm trying to use here. What it's actually doing is going out to this HTTP URL with a script tag and then running that code. And that code is whatever code happens to be served by that server at that point in time. And so this code can change out from underneath us. And so what this really means is this is a package that effectively bypasses our lock file, right? Like our lock file in NPM is designed to lock down the code that our app is depending on so that it doesn't change from build to build, right? It's so that it's deterministic. But when you have a package that's just going to go out and load whatever happens to be on this HTTP URL, you're going to have your app change out from underneath you. And that's exactly what happened here. So the attacker was able to get their code into ConnectKit, which this CDN here started serving, and then all the websites out there, which were actually, I believe, in the thousands, started instantly serving the malicious code without an update, without a new build, without a new npm install. It just instantly updated all the sites. That's how script tags work. And that's, by the way, why script tags are so dangerous. You're just giving kind of remote code execution capabilities to whatever site you use there. So what did we learn from this? I would say there's a bunch of things we learned. Let's go through a few lessons. So for authors, I mean, the main lesson is don't hot link to CDNs from within your NPM packages, because you're going to be bypassing your users' lock files, which is not cool. Also, just related to that, there's a lot. Sometimes you'll see packages that are using HTTP dependencies or Git dependencies, or even like GitHub URL as a temporary workaround to fix a bug. You'll see like a fork. People depend on a forked version. This is really dangerous, because you're bypassing your lock file, and you're giving the author, or you're giving the author of that package the ability to change the code out from underneath you. The other thing was, obviously they didn't revoke the npm access of the employee here, which is a serious problem. So I would kind of advise everyone to audit their npm access pretty regularly and have a checklist for when you're offboarding an employee, so that you can make sure to not forget a step like removing their npm access. And finally, I would consider using a GitHub action workflow so that you don't have to actually give developers access to npm. Now, on the user side, the most important lesson here is don't use packages that remotely load code and bypass your lock file. Vet your dependencies. The only way you're going to find out that a package is doing something like this is if you actually look at the code of it. Obviously, that's a lot of work, but as much as you can, spend time looking at the code in your dependencies, understand what your dependencies are doing. This is not just for security. This will make you a better programmer. You'll learn about different coding styles and techniques, and it's actually just a good idea in general to learn. But you'll also discover when you're using a low quality dependency. And then the other option is you can just use a security tool that detects these types of risks. So not detect vulnerabilities, but actually detect supply chain risks and code quality issues like this one. And so general advice, also use fewer dependencies, pin your dependencies, avoid mutable references to dependencies that can change out from underneath you. So there were some folks using vulnerability scanning tools such as Sneak that weren't protected from this attack. Well over 12 hours after this package was compromised, these tools were still reporting that the package had no known security issues to all their customers. So if you rely on a vulnerability tool, you have to be aware that they're also not going to protect you from this type of attack. And unfortunately, this is, to me at least, I find this so frustrating because on the one hand, our tools are literally not detecting the attacks like this that we actually care about, that are these attacks that are affecting the ecosystem, and yet despite that, they also are drowning us in alerts. I mean, they're flooding us with meaningless alerts all the time. 60% of people have said that they're the number of alerts, so alert fatigue is what it's called, has created friction between their developer teams and their security teams. And I'm sure we've all seen the NPM audit output where you install a package and you immediately see that it has 100 plus vulnerabilities, and then you just shrug and move on with your day. So it's I just personally find it really frustrating that our tools are constantly yelling at us about security vulnerabilities, but yet they can't even detect the type of vulnerability we just discovered. Dan Abramov kind of wrote this famous viral post a few years ago about how NPM audit was broken by design. I mean, he had some pretty harsh words about kind of the problems with NPM audit. He called it a stain on the entire NPM ecosystem, and said it was completely broken. And while I might have chosen different words myself, I do think there are several problems with NPM audit. I mean, it's both sending too many alerts and it's sending not enough alerts. And I don't mean to pick on NPM audit here. This is true of all of our security vulnerability reporting tools. So this, on the one hand, it sends too many alerts about stuff we don't care about, but it also doesn't send alerts about this, about dangerous packages, malicious dependencies, typo squad attacks, and so on and so forth. So that's what we're trying to change with Socket, and we're trying to give this protection to the whole ecosystem. And one of the things we found that really, really helps, and I think this is a really, really cool use case for AI, by the way, is that we can identify threats by passing source code into an LLM. And then that LLM can output a plain English explanation of the risks of the code. So, for example, that ledger attack we just discussed would get this output, describing the fact that there's obfuscated code and there's likely malicious behavior, and so on and so forth. So in the last couple minutes here, I wanted to just show you a couple more attacks to give you a taste for just some other kind of fun security risks of different NPM packages that we've discovered. So let's look at this one here. So this is some code published to an NPM package. It's been obfuscated, so designed to hide the behavior of the code. You can see here it's clearly there's a bunch of functions that have been renamed to be hard to understand. But let's highlight a few of the kind of interesting parts. So you can tell here it's downloading some type of an executable file, which is kind of sketchy. And then here, if you scroll down a bit, you'll see that it's loading something from the Discord CDN. It's using child process probably to execute that executable file. And you can see that there's also references to other executables and some HTTPS stuff. And so it turns out if you take this code and you put it into an LLM, and Socket does this, you'll get this amazing explanation that just tells you what the problems are with the code. So it'll tell you that it's highly suspicious, and it has arbitrary code execution, downloading code from untrusted sources, and it's a significant security risk. So I just think this is pretty cool. If you haven't had a chance to play with LLMs, I actually do think they're going to make a really big difference in the way that we do security, because they just they aren't fooled as easily as a human, and then they also can be run on more source code. They're tireless, unlike a human who'll get tired of reviewing code at some point. And then I wanted to show one other example of even kind of more interesting obfuscation than the last example. So this is a package that we found where it's collecting a bunch of environment variables that it's attempting to steal. But I just thought it was interesting to see here down here how they were trying to evade detection from certain tools, and you can see here that they're calling this type function, and then that's that's pulling some method off of the HTTP object there that it then executes. But let's take a deeper look at the type function and see what exactly is it doing. And this, I just think this is so cool what this attacker did here. So let me draw your attention to down here where they're calling the prop getter function and passing in the series of 0, 1, and 2. Let's just focus on 0. So it calls the prop value function, which then calls this kind of filter operation. And what it's doing is it's actually it's treating the prop getter function as a string, and then scanning the body of the string of this function to pull out the lines that start with // which are the comments. And then what it gets is an array with 3 words in it: West, question, and Ireland. Okay, so then once it has that, then it uses these indexes down here to slice out pieces of these strings, and those are byte offsets into the strings. So let me just show you what I mean here. So it's actually pulling out between the range 2 and 4 on the first string, which is the letters ST. Then for the next string, it's taking 0 to 3, which is QUE. And then for the third string, Ireland, it's taking out R and E. So what could this be for? Why would it be slicing these different strings and pulling out these different letters? Well, I'll give you a hint. It then reverses the string. And so now take a look at the order there. What does that spell? Well, you have REQUEST. It spells the word request. So all this code was literally just designed to return the string request. And then if we go down here back to this original code, you'll see that it's basically just putting the word request there into the file. And so they were just trying to hide the fact that they were making an HTTP request. And so let's see what the LLM, what the AI says when it looks at this code. It turns out it actually was able to figure it out. So all this work that I had to do as a human to kind of understand this code was figured out instantly with AI. So it said here that this code sends environment variables as base64 encoded data, and it even figured out that prop value function that we just looked at is obfuscated, and that this whole thing is used for malicious data exfiltration. So I don't know, very, very cool in my opinion. I think that's just really cool. So the attackers are very clever, but so are the defenders. We have powerful tools now at our disposal to try to protect our applications from these kinds of attacks. So yeah, I'm gonna just leave you with one final thought. Vulnerabilities have the vulnerability system has a problem. It's really noisy. It doesn't really detect the types of attacks we've been talking about in this talk. And so I would just kind of encourage the community, encourage us all to take a broader picture of what does it mean for, what does open source security mean? And there's really so many different sources of risk and sources of problems and packages. It's not just security even, it's maintenance risks, it's unmaintained packages, it's low quality packages. There's just so many things to think about when we're trying to build secure applications. And so I think expanding your horizon and thinking about these things will make your applications not only more secure, but just more robust and overall better for users. So with that, thanks for the time, and I hope that you stay secure out there. Thanks again.